I wanted to go through and explain why these formulas work. So we're going to focus on the intersection of two secants. Not surprisingly, this formula comes from similar triangles, so many formulas we use in geometry do come from similar triangles and setting up proportions of their segment lengths. So I'm going to create some triangles here. I have two secants, PR and TR, that are meeting outside of the circle, and just like in the formula, I've labeled the different pieces of those secants, A, B, and C, D. So I've drawn one of those secants, PR, in blue. So I'm going to create this additional side, PS, and then also with dotted blue, I'll outline RS. So there's this little blue triangle here, triangle PRS. Notice that this angle P is intercepting arc QS. Okay, so let's look at the other triangle. I'm going to outline this one in red. RT is already shown in red, and then I can, with a dotted red segment, connect Q to T. And notice that this angle I created here, T, also intercepts arc QS. That's the same arc that P is intercepting in the circle. That means that those two angles have to be congruent to each other. That's because they're both inscribed angles and they're both intercepting arc QS. So whatever this arc measure is, P and T are both half of that. So angle P and angle T have to be congruent to each other. And then we'll just continue with a red dotted segment here as well. So you can see the red triangle QRT here. Okay, so I have these two triangles. I already know that they share one set of congruent angles, but they also are sharing angle R. So because of reflexive property, angle R I know is congruent to itself, so they now have two pairs of congruent angles. Based on angle, that means that these triangles have to be similar to each other. So if I just look at the triangles where they are, I could set up some proportions based on the corresponding sides. It's kind of hard to see that because these triangles were actually reflected and dilated. So I'm going to redraw triangle PRS over here so that it looks kind of the same as the red triangle. So just flipping it around, I'm moving RS over here. And then we'll do these two sides here. So I'm just redrawing it kind of flipped over so that I can more easily see what the corresponding pieces are. So when I did that, I now have RS over here and P is down here. Okay, so I'm going to label the side lengths that I know from that. SR I know has a length of C, and RP I know has a length of A plus B. Okay, if it helps, we can also redraw the red triangle. I'll just do that quickly down here so that it's separate from the diagram so it isn't quite so confusing. So in that case, we have QRT. QR I know has a length of A, and RT, this entire length, has a length of C plus D. Okay, so now that I have those triangles drawn separately, it's easier to figure out how to set up proportions. So segment C corresponds with segment length A. So I could do C over A is equal to, I'm going to go back to the blue triangle, that would be equal to A plus B over that corresponding side down here has a length of C plus D. So I've just set up the corresponding lengths for two sets of sides here. When I cross multiply, I will get C times C plus D equals A times A plus B. So this is the formula that is usually used, the formula that I taught you or showed you before. And now hopefully you have a better understanding of why that formula works and where it comes from.